So my name's Jay Nordlip. We're here with Steve Millidge, CEO and founder at Payara. And in this Dismiss the Myths episode, we're going to be talking about whether Java EE is cloud native. So Steve's going to be going to a few different things about how Jakarta can run securely and applications versus runtimes, keeping things up to date. And probably a little bit about our Payara Cloud project as well, which I know a few of you have been interested in. As always, if you've got any questions, please pop them in the chat or send them to me directly or put them in the Q&A and I'll get to them and I'll interject when I can. But we will have plenty of time at the end as well, so don't feel like you need to rush. We will get around to all of them. So thank you all for joining us. Whenever you're ready, Steve.
Hi all. As Jaden said, I'm doing a webinar on is Java EE cloud native? And we'll be basically covering this question. I'm going to explore a little bit about what is cloud native and also look at deployment models on cloud native. This is part, as Jaden said, part of a series of webinars. We're asking 6 questions. We've covered 3 of them already. We're up to, well, this is the 3rd, sorry, we've covered 2 of them already. We're up to is Java EE cloud native? Next one, we'll be looking at microservices.
Yeah, we're halfway.
Yeah, we're halfway at the end of today. So our summer series, and we'll be looking up microservices next week. I'll touch a little bit about it on the cloud native topic, but next week we'll look at it a lot more in depth. And then finally, we'll be looking at the deployment model of Java EE, whether that is something that's good or whether it's bad or it's out of date. And then finally, we'll be looking at standards and standard bodies like Jakarta EE and do they matter in this day and age? So the dates are every Wednesday, same time, same place. As I said, next week is microservices, and then we'll finish up just before the summer really kicks off with deployment models. So first thing I'm going to do is look at what is cloud native, because this is a term that is very generic, that's been spread around through the industry a lot, and there's a number of definitions of what this actually is. So I'm going to look at 3 definitions and see which ones I like and which ones I don't. So this is the first one. The source for each one is linked on the URL down there. So this basically talks about cloud native is about exploiting the cloud computing delivery model and building applications and running applications that use that computing model. So what is the cloud computing delivery model is probably the obvious question from that. And from my perspective, what is cloud computing is, or what are the unique aspects of cloud computing is effectively the infrastructures on demand. And that means our infrastructure and our compute infrastructure is what many people call elastic, which means that it can expand and contract rapidly, which is different from traditional on-premise data centers where you may have to raise a request and a ticket to get access to some compute, some machine, some computer or some hardware or some VM, get provision for you. With cloud, you can do that in seconds. The other big thing about I think is big about difference between cloud is a lot of the software, sorry, a lot of the infrastructure is software defined. So what I mean by that is you have APIs where you can set and configure all your compute network, disk, storage, infrastructure. And you can do this, let's say, from software. You can do this from continuous integration, continuous development, or from scripts, or it can all be software defined. And one of the other big areas of cloud, which is probably not a positive, but is the reality, is that cloud platforms like Azure, AWS, Google Cloud, they all come with a whole host of proprietary APIs. There's not a lot of standards around there. Each API is different. So Amazon's API for, say, configuring a load balancer will be completely different from Azure's. So you do come quite heavily tied into your cloud provider. So when we talk about, in this definition, cloud native, for me, this means exploiting that elastic software-defined infrastructure. and running, as we're talking in this webinar, and running Java EE applications on that infrastructure. I'll look at another definition. So this is the definition from Cloud Native Computing Foundation, CNCF. Again, they've got the similar from InfoWorld. They talk about building and running scalable applications in dynamic environments, such as public, private, and hybrid clouds. But they go in the second sentence, what I would say is slightly a step too far. So then they talk about containers, service meshes, microservices, immutable infrastructure, and declarative APIs. And this is true in the sense that this is what the Cloud Native Computing Foundation concentrate on, creating service mesh technologies like Istio, talking about microservices, but it's not fundamental to cloud computing. You don't have to run a service mesh to run on public cloud, for instance, or build elastic infrastructure. Service mesh is effectively a reinvention of SOA and service buses on top of Kubernetes. But obviously that is the focus on the Cloud Native Computing Foundation, so they call that out in their second sentence. And then we're going to look at a third, and this is one that I effectively disagree with. So this is actually Red Hat's definition of what is a cloud native application. So what they've basically stated is cloud native applications are small, independent, loosely coupled services. So effectively they're linking cloud native with microservices. And to be honest, I think that goes too far. To be cloud native, as in something that can run on cloud infrastructure, doesn't mean to say you need to build a microservices architecture. Microservices architectures can be built on top of on-premise data center, infrastructure. So there's no need to me to link the two together. And so there's a lot of confusion. So in my view, there's 4 different aspects of the industry that are colliding into this cloud native terminology. So what we have is microservices. Like I said, we'll explore that a little bit more next webinar. We'll talk about some deployment models on cloud for microservices in this webinar, but we look at Jakarta EE, Java EE support for microservices in more detail next webinar. We have containers. So this is another area where people sort of equate containers to be cloud native. But obviously that's not necessarily true. It may be a good thing to use on a cloud platform, which we'll explore, but it's not necessarily a defining feature of cloud native. And then we have the 12-factor app, if people have heard of that, which is a sort of model for building applications, I suppose. Many of the features, I won't go into all the features of a 12-factor app. It's very easy. If you quickly Google it, you'll get a list of the 12. It's written as a sort of prospectus, if you like, for how to build an application. But many of these are good practices on cloud, but not necessarily requirement for your cloud native application. So for example, it'll cover things like you have one code base tracked in revision control, which you can then deploy many times. Well, you can do that without being on a cloud. It talks about explicit declare and isolate explicit dependencies. Well, if you're building a Jakarta EE application, your dependencies will typically be the Jakarta EE bill of materials. So that's obviously easily done. And then there's things around external config in a 12-factor app, separating build and run phases, which, let's say, Java EE does really well, and building stateless processes, which are more scalable by definition because they're stateless. Well, we've talked about stateless processes since building server-side applications in the noughties and 90s, being more scalable. So all of these things are clashing around how to use public cloud. So for my definition or my concentration, if you want to think of cloud native, is really, again, focusing down on what is unique about public cloud. And that is elastic infrastructure. So you can scale out, scale down rapidly. You can get infrastructure on demand. You can stand up new machines for testing. You have proprietary APIs to manage infrastructure. So focusing down on that, what we're going to talk about in this webinar really is deployment models of how you can use cloud infrastructure to deploy Jakarta EE applications, and we cover quite a few of those deployment models. To show you that it's very easy, there's a lot of options to deploying a Java EE Jakarta EE application onto public cloud. First thing I'm going to do is talk a little bit about, there's two different models of deploying Jakarta EE Java EE applications that are around. So we have a traditional application server model, which if you were at the last webinar, I talked a lot about. But here you have a complete separation of your application, which is typically a WAR file or an EA file, and your application server. And you deploy that application into your application server. And your application server is taking care of many of the services that you need, your application needs, like networking, security, database access, threading, all those things are wrapped up within your application server. The second model, which is quite popular as well, is what's called a fat jar. In this case, all you're really doing is you're packaging your application with your application server into a single jar file, which you can then run on the command line with a Java -jar. So the Payara platform supports both of these models. So traditional deployment would, for example, be Payara server, which is a traditional domain, and we look at, does that make sense in a cloud application? For example, is Payara server cloud native? We'll cover during this webinar. And then we have the fat jar, which is typical for Payara Micro. So Payara Micro, again, is a Jakarta EE runtime and can run your application and package it up into a single jar file. But it covers the same services as Payara server. But you can run it straight from the command line with Java -jar. And then related to that, I'm also going to quickly look at, which is a slide from Kubernetes website, which is the evolution of compute infrastructure, because I think this sums up really what has happened for cloud and where these things are clashing and meeting in the middle to give you cloud native. So traditional deployment, where you would have your computer, your hardware, your physical server, you have an operating system, and you deploy multiple applications on your operating system. And that's what we call the traditional deployment. And then obviously virtualization came around. On top of the operating system, we gain a hypervisor, and then we can wrap up a whole bunch of full computer images effectively into a virtual machine. So we have the applications deployed on top of an operating system, on top of a virtual machine, on top of a hypervisor, on top of a physical server running as operating system. And this is really what created, the birth of cloud computing, as opposed to what was before that, where you would just use dedicated servers at a hosting provider, for instance, and you'd order a dedicated server and it would turn up sometimes within hours, sometimes within days. So what virtual machines allowed you to do is create multiple things and share the computing. So compute power of underlying hardware and extract the two from each other, which gave, basically came to the birth of public cloud providers like Amazon with their EC2, which when EC2 came about, it was effectively virtual machines running on their hardware infrastructure. And then we moved to containers, again, quite a long time ago. Docker came around. What Docker does and container does is it sits on top of the operating system and creates what's called a container runtime. And the container runtime is not the same as a hypervisor, because it's basically a hypervisor is emulating a whole computer, whereas a container runtime is just using logical file systems and basically creating a logical copy of the operating system. It's not actually making a copy of the whole machine. And you package up your application into a container, which basically locks up your configuration of your application and the sort of file system layout and libraries and things that you're using, and then puts it on top of a logical instance of the operating system in the container. Think of it in simple ways. And this moves into where we're going now with containers and container instance services and Kubernetes and all those things are basically operating on the container level. So how do we take different application server deployment models like a traditional Payara domain or a Payara micro, and how do we map that to this effectively the cloud native infrastructure, which is virtualization and container deployment. So I'm going to go through a number of scenarios just to show that this is part of what the job of an application server is. So here we look at, can you deploy, for example, in a typical Payara domain, and how would you deploy it onto a public cloud? This could be Amazon or Azure. And we've got lots of documentation around this, which we can send out to people, or you can just look on our website. We have a whole section on cloud deployments. And really, to me, cloud native really is a function of which application server or which platform you choose to run your Jakarta EE applications. Do they support these modern infrastructure, these modern or containerized deployments? So I'm going to go through, like, say, a number. So this one would be typical VMs. So for Azure, you have Azure VMs, and for Amazon AWS, you have EC2. And basically, Payara domain is built, and Payara 5 has specific support for these platforms. So in here, what we have in this picture, we have a load balancer. So on Amazon, that would be an elastic load balancer, or just a standard load balancer on Azure. And building on the elasticity of the cloud infrastructures, most of the cloud providers provide you something called, in Azure, it's called a scale set. I can't remember what it's called in Amazon, or an auto scaling group. And what that allows you to do is to create a virtual machine image and scale it out to say, oh, I want 6 of these, or I want 5 of these, or I want 4 of these. And these are typically linked into the load balancer in the cloud computing, so it will basically load balance depending on how many of these virtual machines you have. So Payara 5, we've done a lot of work to make it cloud native for this sort of architecture. So recently we created something called an auto scale group, which will basically, as we build it out, that feature out, will allow you to actually call the public cloud APIs to scale out virtual machines for you. But out of the box now, so Payara, if you create this architecture, it will automatically cluster your application instances, and they will do that on different public cloud platforms, and it can do that automatically. It will also enable you to create VM images with instances on, which we call a feature called dynamic instances, where you can add and remove instances on the fly from the domain. And we have something called a deployment group, which means that if you add an instance into that deployment group, then the applications that you configured and the configuration you've set will automatically be propagated. So out the box, so Payara can support, Payara server domains can support a traditional application deployment. So that you don't have to have microservices, for instance, to work in a public cloud environment, to have elasticity and auto clustering and scale out and scale down. Payara server in a traditional domain can support that now. So you could take a standard application and it would be cloud native. So the next one we're going to look at is containers, so just raw containers. So this is working on virtual machines. If you remember the previous slide, the next sort of evolution was to work on containers. And we have solutions for containers as well, running natively in public cloud. The two main container services for example, Amazon is the Amazon Elastic Container Service that allows you to just create a container and spin it up without worrying too much about VMs and what the compute infrastructure is. Amazon will just provide some. And similar on Azure, it's called container instances. So again, Payara platform fully supports these. So what you would do is you create your container image using Docker or something like that. You package up, in this example, we're packaging up SUSE Linux with a Azure platform, which you get as part of your subscription with Payara Micro, and then you put, say, a microservice on top of it. It doesn't have to be a microservice. It could be any web profile compliant application. Or you could potentially put Payara server also in that image, and you could have any Jakarta EE deployment. And then you package that up, send it to the container service, and it will fire up a container and run it for you without you worrying about server management or host management or virtual machines. And then from top of that, you will put on a cloud load balancer. It's a bit more complex depending on the cloud provider to auto balance across containers, but typically the cloud providers will allow you to create multiple containers for the same application and a load balance across them. And again, we have built specific capabilities within the infrastructure of Payara, the Payara server, runtime, or Payara micro runtime to support clustering, session replication, all those things across containers within this sort of infrastructure. So you can take advantage of container services within public cloud using the Payara platform. So Jakarta EE has some advantages if you are building this sort of architecture, in that if you're building container images, then we have effectively 3 layers. So container images are built on layers and they are effectively configuration controlled. So the bottom layer, you have your base operating system. We then have the application server layer or managed runtime layer, and then you can have your application layer. And container images are typically quite large because they package up effectively a whole operating system image and drop it into a single file, which can be megabytes to gigabytes in size. And the layers are there so that you only have to change a small sort of diff, a small piece of the operating system, the file system, so that you can update the layer on top. So from a Jakarta EE perspective, the application layer will change quite frequently, but it's separated from the application server tier. So you can build container images quite quickly and update small changes and push them out onto the cloud quite rapidly, because typically the application layer changes will be quite small, in kilobytes, hopefully, or potentially megabytes, as opposed to potentially gigabytes for a whole image that you would push. So there's advantages in the Java EE Jakarta EE application deployment model. The next level up from containers on cloud is effectively Kubernetes service. So what is Kubernetes, I suppose, is the first question if you don't know. I won't go too much into that, but effectively it is a platform which is, in quotes, standard, in that most of the cloud providers support it, which allows you to manage containers at scale. It's not like an application development solution. It is an infrastructure technology that allows you to manage containers at scale. And what do I mean by that is it provides services for load balancing containers, service discovery, so you can create what's called a service, which is multiple pods, and you can scale that out. It'll manage storage, so you can attach and remove file storage, blob storage. It can do rollouts and rollbacks of different configurations of your containers or pods. And it can do what's called bin packing. What that effectively means is it can work out which physical compute that it should run your containers on and choose the best physical machine to run your pod. And it can do some secrets and basically security management as well. So how would you do? So basically running a Jakarta EE application on Kubernetes in this mode is very similar to running on, say, Azure container instances. The difference is Kubernetes is as a standard, so in the sense that it's supported by Azure and AWS and GCP. So if you build your infrastructure on Kubernetes, then it's likely to be a little bit portable between the different clouds. Whereas if you build it on Azure container instances, then that's completely Azure proprietary. So it looks exactly the same. So what we'll be doing is building a container image, including our Jakarta EE application, Payara Micro, our JVM, and our operating system. And then we would then have to create what's called a pod definition. We'd have to upload that into Kubernetes through some cryptic YAML. And then we can then scale out and scale down scale up, scale down the pod using pod autoscalers. And again, Payara platform has this functionality built in. It can work and cluster in a Kubernetes through using the service names. And you can build container images using Payara Micro or Payara Server and scale them into on a Kubernetes platform. And if we move to more traditional architecture, we've built capabilities to do similar for a domain. So you don't need to build microservices. You could build a traditional application server domain into Kubernetes. So we have what's called a Payara Kubernetes operator. What the operator will do will actually build out all the infrastructure. If you drop that into Kubernetes, it will create the instances and the pods and the admin pod and the instance pods that you need to build a traditional Payara server domain on top of Kubernetes. So again, if you're using a cloud Kubernetes service, then you can take a normal Payara domain and build it out onto Kubernetes. As I said, we're building out functionality to allow you to scale out and scale down from the admin server, but you can still do it with pod scalers and dynamic instances, and they will cluster, and you will be able to build clustered Jakarta EE application servers on top of Kubernetes. So, and then later on, we'll be producing Helm charts, which allow you to, again, install all this from scratch. So, from a cloud native perspective, from a Java EE, the APIs themselves don't really matter. If you have a Java EE application, if it's what really makes it cloud native is what you choose as the platform to take that WAR file or EA file and deploy it to. So what you need is the application server to manage that infrastructure for you, and then you have a Java EE cloud native application because it's going to run natively on cloud infrastructure, and you will be able to scale it out and scale it down, use Elasticity Cloud, and build out and deploy that application natively into public cloud. One of the other areas, though, as I spoke about, is there's a lot of proprietary APIs around within cloud. So we need to look at, how you use those, and we have built a whole bunch of connectors which allow you. So these are examples of messaging connectors. So we're spending a lot of time building out connectors for Java EE developers. So these are a set of JCA adapters we've created. This is a screenshot of the website for Kafka, for Amazon's Q service, for Azure's Service Bus, which again is a Q, MQTT, which is a protocol that a lot of the event servers on the cloud platforms use. We have standard connectors for these. The advantage of using our connectors over, say, just using the service API is one, the service API will be proprietary. The second one, though, is that we need to integrate things with Jakarta EE model. So, for example, if you use the proprietary or the standard API to DQ a message from Amazon's simple Q service, for instance, SQS, then you would need to somehow establish a Java EE context if you wanted to then start using entity managers, session beans, CDI, stuff like that. So our connectors do all that for you, so you can just integrate with these technologies. Other one is security. Obviously, there are different security protocols that are on different cloud providers, and again, our Payara platform integrates with standard security providers like OAuth and OpenID, LDAP, including Active Directory and things like that. So we can integrate, and our job really is to build this sort of ecosystem to make your applications natively operate with the services provided by the cloud providers. So again, using standard Jakarta EE like Jakarta Security, things like that, we can build these connectors for you so that your applications can use them and be in the correct context for the rest of the application code. Now I'm going to diverge a little bit and look at, okay, so what if we accepted that all this is infrastructure? This is all software-defined infrastructure. Is there a way we can completely build a cloud native runtime for you as a developer, or as an architect that needs to deploy, a Jakarta EE application. So this is what we've been doing. So again, if we go back to the traditional deployment model, what we see in Jakarta EE is that we separate our application from our compute infrastructure and our runtime. And what I mean by that is you create a WAR file or you create an EE file. And then what you do is deploy it. So some of the work we've been doing recently is to look at, instead of, taking the models that we've described, packaging up Kubernetes and creating containers and creating pod definitions in YAML and things, all that, which is infrastructure work. What if we took this model and applied it to the cloud? This is what we've done with our Payara Cloud offering, and I'm going to talk a little bit about that. The idea of Payara Cloud was basically a 3-step process. What we wanted to do is take what the Jakarta EE developers understand is deployment, but apply it to the cloud. So our view was that what you should need to do is take your application, your EE file, your WAR file, go on to a admin console or later on into CLI, a command line interface, and click deploy, upload and deploy, and then your application runs on the cloud. And this is how we're building Payara Cloud effectively, again, to show that separation of application from compute and application services and application managed runtime is a great benefit of Java EE. So for Payara Cloud, what we'll do is we'll log in. You have a set of namespaces, which are effectively like a grouping, so that if you had microservices that were all together in a single application, you could create them in a single namespace and they'd be able to talk to each other. And then you would upload your application, hit deploy, and it would deploy, and that would then run and give you a URL where you can access it, just like you would do in a standard application server. And this is what we're building with Payara Cloud. And ultimately, this is what we're building and the whole platform as a solution for, making the running on cloud even easier for developers. So what's happening underneath? So this will give you an idea. So what we're doing underneath in Payara Cloud is building all that infrastructure, those deployment models that you can build up yourself. As I mentioned, the Payara platform is cloud native. It will operate in cloud environments. So you would take your WAR file, you'd hit deploy, and what Payara Cloud does is it does all that tedious infrastructure configuration that you need to do to get something running. And on our case, we sit on this on top of Kubernetes. And we sit it on top of Kubernetes so that we can then sit it on top of Azure, AWS, or GCP, or whatever, or potentially on premises in the future. So basically, we can take this and then run it anywhere. So when you deploy, what Payara Cloud do is takes your WAR file, packages it up with a Java EE application server, and in our case, Payara Micro, builds it into container image, creates all the Docker files, the pods, the YAML files, works out the secrets, all that sort of thing. Allows you to configure external configuration sources, change configuration, connect to databases, and then runs it on top of Kubernetes and sorts out all ingress for you with an API gateway. So basically, what Payara Cloud demonstrates is that Jakarta EE model is absolutely suited to cloud deployment, cloud native. In fact, we can take this model a step further, and actually we could take this and deploy it onto a complete hybrid cloud. So what we mean by hybrid cloud is there's nothing stopping us building infrastructure whereby you could take your application and you could drop it into one of the multiple Kubernetes clusters. Or you could spread it across Kubernetes clusters. Again, it doesn't do this at the moment, but although you can choose region, so it effectively does, but you can't deploy the same application into multiple regions. But there's nothing stopping us doing that in the future. So because your Jakarta EE application is just a WAR file, then we could deploy and we drop it onto either Azure Kubernetes service, we could drop it into Elastic K8, which is the Amazon Kubernetes, or we could put it onto an on-premise Kubernetes cluster, for example, like Rancher or something like that, or even OpenShift. And then that would run. And basically what we're doing, because we are the Jakarta EE Java vendor, what we're doing is we are managing all this for you as developer so that you can basically build the application and not the infrastructure. Because as I said, the biggest change in cloud native is this infrastructure layer is completely different. And ultimately, what we want to do is we want to separate your application from the infrastructure, and we want to provide a platform that can scale everything from edge servers right up through containers, bare metal, through virtualization, through Kubernetes, and right onto cloud platforms, and allow you to take your application and run it anywhere. So hopefully I've demonstrated that there's a number of options to run Jakarta applications cloud native, from traditional deployment on VMs, where we've done the work to make sure that clustering and elasticity and everything works for you out the box, right through to taking an application and deploying it onto Kubernetes or multiple Kubernetes clusters maybe in the future. So the answer really is Jakarta EE cloud native is obviously yes. We support all this cloud infrastructure. It's our job to support it for you. And it's ideal actually for cloud platform. So, any questions?
Yeah, feel free to put them in the chat, guys, or in the Q&A. I see we've got one here from Richard Grin, which is Payara Cloud compatible with Oracle Cloud?
So, simple answer would be we haven't tested it on Oracle Cloud. When we're going to launch it, it'll be launched as a platform as a service, and it will be running on top of Azure. But as I said, it's running on Kubernetes at the moment. So there's, other than time, there's nothing stopping us running on any cloud platform that will support Kubernetes. It'd take a little bit of work from the application provisioning side, mainly because most, as I said, public clouds have proprietary APIs for ingress and load balancers and those things, but it's our job to fix that and abstract that away.
Okay, brilliant. At the minute, no other questions I can see. But if you guys do think of something later, feel free to either message us on social media or go to the website and send us an email. And I can make sure Steve gets a look at it and we can get an answer for you.
Okay, these are the other webinars we have. So say next one will be microservices, 3 p.m. BST UK time or 4 p.m. European next week. And we look at microservices, look a bit more into microservices APIs that's supported and how you can build microservices and deploy them. Oops.
What I'll quickly do as well is I will quickly drop the meetup group link in the chat. So if you want to be able to see any of our other events coming up, that's one of the easiest places to find them as well and to get reminders. With Reef, that is our engagement community growth program, where if you are working on Payara-related projects or want to get involved with Payara, then we are certainly open to collaborating and working with you guys and possibly supporting your projects or Java user groups in a way that benefits everyone. And if that is no further questions, then we will finish up.
Thank you.
Well, thank you all very much.
Thanks.
Cheers. Bye.